Hi everyone. Today I'm going to be unboxing a new Aranet4 Pro CO2 sensor. So these instruments are designed for use indoors, either in your home or in a business, to monitor CO2, carbon dioxide concentrations, temperature, and relative humidity. So these are important factors when you're considering indoor air quality. CO2, so there's a sensor, it has e-paper for the display, it runs on batteries. So carbon dioxide is emitted by people or animals breathing indoors, and also by activities like if you cook with gas or burn a candle or something like that indoors. And if a space is well ventilated, then the CO2 will be swept away and air will be replaced with fresh air. So we know that there's CO2 in the fresh air too, and the concentration outdoors is something like 414, 415 parts per million, usually. CO2 is not a highly reactive gas, and so the concentration is actually pretty constant because the gas gets well mixed throughout the at least the northern hemisphere. And so, you know, the typical baseline CO2, as long as you're not right next to a source, like behind a car's tailpipe or something like that, is similar in New York as it would be in Chicago or anywhere else. So this particular sensor exploits that in order to do its calibration. So the batteries are in. So normally, if you're going to be calibrating a sensor, you need to do it in a lab with some gas, like specialty gases and a reactor. So you're going to control the concentration of gas that the sensor is exposed to, and then you'll calibrate it that way. But this sensor, since we can make some assumptions about what the concentration of CO2 is outside, this one can be calibrated, you know, at least approximately pretty easily just by sitting the sensor outside for a while and letting it reach the steady state value. So another nice thing about this particular sensor, so you can see the value is a little bit high. This is probably the value that it was inside the box where it was. It's going to start going down as it equilibrates with the air in the room over time. So you can start to get a sense of the time response of the unit also. Okay, another cool thing about these sensors is that they connect via Bluetooth to a phone or a other device like an iPad. So I'm going to connect this to my son's iPad, which normally is exclusively used for watching Wildcrats by my younger son or doing weird coding things by my older son. All right, do I want to pair the device? Yes, I accept. It's telling me a PIN number that I have to enter. Okay, it's pairing. It's asking me to name the device. This is the second Aranet4 Pro that I have on hand, so I'm going to name this Pro 2. And we're waiting for it to start acquiring data. So a cool thing that I can do with Zoom is actually connect to the iPad and share the screen with you. So it should be happening. Yes, boom. Okay. So this is the way the app looks on the iPad. The silly sensor still says it's 956 parts per million of CO2. We're waiting for it to acquire the data. Once I do, once it starts acquiring, I can click on the graph. And it will show us the concentrations of CO2 with time, temperature, humidity, pressure. Okay. All right, I'm going to check this sensor out and figure out why the value hasn't changed yet, and get to the bottom of this. One problem might be the frequency with how often it's collecting data. So I'm going to go to settings. It says it wants to collect data every 5 minutes. Let's wait for the screen to update on your side. The mirroring is not super fast. All right, I'm going to change from 5-minute intervals of collection to 2-minute. Okay. And do an extended Bluetooth range, just so we have better connectivity between the iPad and the sensor. All right, so I am going to check out this bad boy and figure out why it's not collecting data like it should. It's crazy. All right, I'm going to put the batteries back in and see what happens. Anything? Ooh. Starting up again. What? Great news, guys. We gave it a little bit of time, and our Pro 2 has started behaving a little bit more normally, like what we might expect. So let's take a look at the iPad. Come on. So that high CO2 concentration that was being recorded by the unit might have been real, at least for what it had in the box. And so now we're down to 533 ppm. I can make that go up. Right. May take a moment. Come on. I'm gonna look for Pro 1 also because that one has a much faster time. Oh, there you go. Crazy high CO2 levels. You would not want your whole room to be filled with exhaled breath. That would not be healthy. CO2 levels higher than 1,000 or so in the room give you a headache, make you work less efficiently, have confusion will set in. But that's a great example of an impulse input to the unit and its response. So now we're going to see another decay slowly going down. And I'm going to place it outside so that it equilibrates with air at roughly 415 ppm CO2, and I will calibrate the unit to make sure that the baseline level that it's always returning to when we're looking at the ventilation inside the room is in agreement with what we expect from outdoor air.